Large language models can follow complex logic with high accuracy when they operate within a controlled, isolated environment. Yet, when organizations attempt to deploy these same models into actual day-to-day operations, the pilots almost universally stall. The agents hallucinate, lose context, or fail to execute tasks that seemed simple in testing. The models are capable, but the business context we feed them is chaotic. Look at this scattered web of emails, PDFs, spreadsheets, and folders. Without structure or consistent conventions, an AI has no reliable way to map relationships or establish context. The solution requires an intermediate infrastructure. Messy inputs must be routed through a centralized, structured data layer before reaching an agent. By passing raw information through this layer first, data is normalized. Let's break down how to architect this system and sequence a reliable workflow. Constructing reliable enterprise AI is a challenge of systems architecture. A persistent misconception in enterprise IT is that AI agents can simply be plugged directly into existing systems via perfect APIs. The reality is fragmented. High-value work happens in scattered sources: external portals, inboxes, PDFs, and legacy tools. Pointing an AI directly at these formats introduces significant security risks. That is why every input must pass through the structured approved access layer first. Before the AI is allowed to read a single byte of information, the system must enforce strict role-based approvals and multi-factor authentication. The model can only see what the current user is explicitly authorized to view. An approved access boundary is a mandatory first step. Without it, your most critical real-world data remains off-limits for safe automation. Once the access boundary is established, the raw data needs to be translated into machine-readable context. The underlying information system has to be built into a usable stack. This diagram maps the structured operating layer. Layer 1 normalizes records. Layer 2 links related documents. Layers 3 and 4 enforce strict permissions. Finally, layers 5 and 6 add workflow triggers and a human review trail to safely govern behavior. This entire 6-layer structure serves as a translator. It takes chaotic human workflows and converts them into a rigid, deterministic environment where a language model can operate safely. Most consumer AI experiences are built around open-ended chat, which is highly unpredictable. Enterprise operations require a different approach. A reliable agent follows this deterministic 6-step workflow. Steps 1 and 2 receive a prompt and pull approved context. Steps 3 and 4 draft an action based on that data. Finally, steps 5 and 6 mandate human review before execution and logging the outcome. By forcing the model through this sequential path, organizations eliminate the risk of an AI jumping straight from a prompt to an unapproved action. To see how this architecture prevents errors in high-stakes environments, we can look at a specific construction management workflow. This panel illustrates the schedule and risk agent. Notice the timeline and risk alerts. It actively monitors for missing dependencies. It generates specific warnings, like flagging a concrete delay, because the underlying data explicitly mapped its dependency to the subsequent MEP rough-in. When the delay is detected, the agent leverages the deterministic 6-step workflow we just covered. It identifies the issue, drafts a detailed notification, and holds it for the project manager's review. The intelligence displayed by the agent is a direct product of the rigorous data mapping beneath it. The best AI models simply surface the logic that you have already embedded in your data layer. Deploying enterprise AI naturally raises concerns about autonomous software executing unauthorized actions or sending sensitive communications to clients. Production-ready systems keep humans in control. This approval queue manages AI outputs. Drafted actions, like delay notices, wait here. The operator retains total governance, able to approve or revise before anything goes live. Finally, an audit trail logs every intervention to improve future performance. Human approval is a fundamental feature required for safe, accountable corporate automation. The core challenge is operational. Reliable outcomes start with building better data environments, rather than just seeking better models. This 3-step flowchart outlines the precise roadmap for deployment. First, assess your existing workflows. Then, invest the time to build the structured data layer. Only after achieving data readiness should your team pilot specific AI agent use cases. Highly structured systems provide the foundation needed to turn technology hype into reliable business outcomes.